Day 6 homework, page 120, number 38. The basic idea here is that the change in momentum, delta P, equals the impulse, if we call impulse J. And impulse is average force times time. So delta P equals F average times time, because J, impulse, equals average force times time. And I should have said that delta P is P final minus P initial. Momentum final minus momentum initial. And in this case, what you're kind of assuming is that the water in the hose has essentially no speed before it squirts out the hose. So the initial momentum of the water is essentially zero. That's the assumption. So basically the final momentum of the water is the average force times the time. And momentum is mass times velocity. So we have basically mass times velocity final equals average force times time. And we're looking for average force. So it's going to be M times V final over T equals F average. Okay, the shortcut here is M over T. One way you could approach this problem is just pick a time, like 1 second or 2 seconds or whatever. The best would be 1 second. You'd get 1 kilogram of water. But bottom line in this equation you see that I just wrote down in red at the bottom, M over T is the mass per unit of time. Well, we already know the mass per unit of time is 100 kilograms per second. So in other words, that M over T is 100. So we have essentially M over T. I could group it like this. M over T, mass per unit of time, times V final equals the average force. Well, M over T is 100 kilograms per second, times the V final, which is 10 meters per second. So it's just 100 times 10 is 1,000. So the answer is going to be 1,000 newtons of average force during this process.